Do y'all have some big test coming up here within the next several days? Huh?
Next Friday's farm and next Tuesday's our denture practical.
Oh, the denture practical. That's what it was. That's what it was. Okay. Y'all got that one covered though, right? Don't they give y'all like 4 hours or 8 hours? Oh my God, 8 hours to set a full arch of teeth. You can
No,
set
both
you can
arches.
set in two arches. You can set 2 hours. It should take you 2 hours.
I did it in 5.
That's good. That's good. That's good. Okay, we need to get started here because we got a lot to cover. So, uh, anybody ever been to this part of the country before? Anybody know where this is? It's in France. That's very good. Very good. What is the name of this thing? What is it? What is that? That's actually sitting out in the water off the coast of France. Yes, that's Mont Saint Michel. Have you been there? Okay. Neat place. There's a road that leads out there. That's actually, I think it stays above the tides because it's built up kind of high, but the rest of the area is underwater. So it was kind of a protective mechanism back in the day uh, for invasions. But there's a whole city built around this little island, and there's a church up on the top. I think there's a monastery up there too. So it's kind of a neat thing. One year, the Tour de France had one of their stages by this facility, and it's kind of neat. But they won't let you drive in on the island, so you have to be like a vendor or something, or live there to actually drive a car or a truck there. So you get to park out in the parking lot and 2 foot it around the island, which isn't too bad, but it is a little steep. That's where it's located, right there, just off the coast. In case you're interested. Okay. So today we're going to be fitting our bridge frameworks that came back from the lab. Okay, they came back Tuesday, and I only looked at one. No, I looked at a couple of them. I took pictures of one or two, and so you're going to fit those. All right, it's all metal, so you're going to fit it, make sure it fits, and then we're going to send it back to the lab to have the porcelain added on. So you need to fill out a QC sheet, and you need to fill out a new prescription, which is kind of what you do in the clinic. And typically, you will try these in two appointments. One's for the metal try-in, the other's for the delivery. Okay. Okay. So we're going to do the metal try-in today. Then, if it doesn't fit, then you won't have to solder it, but you do need to index it. You need to cut it and you need to index it. So we'll talk a little bit about that and what to look for. So you're going to have a QC form and you're going to get your stuff back, and it should look something like this. This is a conventional workflow. You made some gypsum casts, you sent it to the lab. Actually, yeah, there's a Pendex one right there. And then they make the product, the bridge or the crown, they make it on that gypsum cast. Okay. Now, if you're going with a digital workflow, that's all you get back. It's not fitted to a cast because it's not made for a cast. The cast serves as a die to actually manufacture something to fit. This a virtual file is just a bunch of zeros and ones. Okay. Now you can have a printed cast made, but should it fit the printed cast? It's not made for the printed cast, so sometimes you have to fit it to the printed cast because the printed cast doesn't fit. Okay, so that does. But if you're making it on a gypsum cast, it should fit the gypsum cast, and so that's what you're going to verify. Does it fit the cast that I made? All right. So, and this is kind of a hybrid workflow. Some dentists don't know what to do without a cast, so they print me a cast so I can see how well it fits. Oh, do you hear yourself talking? Do you not understand the workflow here? It's not supposed to fit the printed cast because it wasn't made on the printed cast. It was made by X's and O's, zeros and ones. So it doesn't always fit the printed cast. Okay. Now, if you printed a plastic cast and had it made on that, well, then that would be something different. But I've never heard of anyone doing something that quite that silly. Because if it's a virtual file, just make it, mill it, okay. But you can have it fitted to this. Where does a plastic cast come in handy? One might ask themselves, why would I want one made? Where is it beneficial? When you have multiple restorations made for single units, you don't need it. For multiple restorations, yeah, you're going to need it. For anterior restorations, where you need a custom guide table sent to control your incisal guidance, you need to not only print that cast, but then you need to mount it on an articulator and build the custom incisal guide table. And so we'll have some hybrid digital cases that go to the laboratory like that. Otherwise, if you're just making a single unit crown, well, you don't need to bother. Matter of fact, if you have that printed, cha-ching, okay, you just drove up the cost, your cost. Your patient's probably not paying for that, because you have a certain cost for a crown in your fee schedule, just like we do in the clinic over there, and it doesn't change because we're adding laboratory techniques or procedures. It stays the same. So if you add something like that on there, it's going to come out of your profit loss statement. Okay. All right. This is the QC card. Okay. Put your name on it. You don't need to put a patient's name on it, but put your name on it. And I want you to evaluate the prosthesis. How well does it fit? Okay, are the margins closed? Does it fit? Do I have contacts? Now, where are you going to have contacts? You'll have a distal interproximal contact on your distal most retainer, right? Because that's going to be metal. The mesial one should be in porcelain, so that should be open right now. So if it's in contact, oh, you have a problem. Okay, you might need to open it. Occlusal contacts, you may have to adjust the occlusion, maybe. If you have no occlusal contacts, and I think number 3 is all metal, okay, and number 4, the Pontic, actually has, you should have most of your contacts in metal. Maybe one might be in porcelain, okay, but you will have contacts on number 3 and number 4. Number 5, I don't think there's any metal contacts on there with your PD design option. I don't quote me on that, but you're going to have quite a few occlusal contacts to evaluate today. If there's no contact, then you probably won't have any contact towards the end. So how are you not going to be penalized for that? You put it on the sheet. This is your get out of jail card. Okay. So if you don't write it on the sheet, I keep these sheets, and I bring them back on the day that you're delivering these. And if you didn't specify that you had no contact here, but you don't have any contact at the end, I'm going to assume that you ground it all away, you polished it away. So you'll get penalized for that. But if you get it back and the lab, well, I don't have any contact here. Okay, write it on the QC sheet, and then you will be forgiven. Okay, that's your get out of jail free card. So evaluate it closely. Do the margins look like they're closed? Now you won't be able to tell. I didn't pay any attention to the porcelain margin. Your metal margin on the metal retainer should be closed. Okay, should be fitting. On the porcelain one, where you do the cutback for the porcelain shoulder margin, sometimes they will wax that out in metal and then cut it back when they add the porcelain, and then sometimes they cut it back before. So I don't know what they did. I'd have to I'd have to take another look at them and see what they did. So you may or may not be able to evaluate the margins on number 5. The lingual side, where it's a chamfer and you have metal for sure, but you won't be able to evaluate the facial porcelain margin until it is completely finished. So look at these. Now you won't be able to evaluate everything. Like there's a shade on here. Okay, well there's no porcelain on it, so you can't evaluate the shade. And quite frankly, I don't care what the shade of it is. It's for a typodont. Matter of fact, I'm going to have you ask them to use D4. Was it D4 or B4? I don't know. It's a real dark porcelain. Okay, it's a color only a European mother would love. Okay, so I do that because I know they have a lot of that dark porcelain sitting around that they really can't. They don't have an opportunity to use it, and it's like, okay, well, we don't care. Just use it on our dentiform patients. They won't complain. And so shade and aesthetics. I don't know if you'd really evaluate aesthetics, but don't just browbeat this thing and sign your name to it and turn in, because it may come back to haunt you. So there's a reason that I have this thing in here. Okay. So the way we do this in the pre-clinic is a little different than we do it in the clinic, and the reason is because your dentiform, it's not that accurate from an occlusal standpoint, and you should know this by now. Okay, we realize that. So when you made the impression, and you've probably taken those preparations out since then, haven't you? Of course you have. And you're gonna put them back. You're gonna find them, right? Because you were supposed to keep them in a safe place. And you're gonna put them back in today, and they may not be exactly in the same place, so your bridge may not fit. Okay, just because you're taking teeth out and putting them back in. So if you have an issue with if it looks like it's just almost fitting but not quite, what I would do is I would take your screwdriver and loosen the screw on both of your abutment teeth, seat the framework down, and then tighten them up. Okay, and we'll see if that doesn't. Sometimes that helps make it fit a little more accurately. Okay, if it looks like it doesn't even belong in on your dentiform, it may not, because they do mix these up at the laboratory. Last year, oh my God, I think they mixed up 5 different cases. So we had 10 people running around here with their heads were cut off. Oh, it doesn't fit. It doesn't fit. And I mean, it like really didn't fit because it was that far off. But we were able to push through and find everyone's framework, and we actually had someone that ground the bejesus out of their framework, and they made it fit, and it was someone else's. So kudos to them for their adjustment prowess, but it should be relatively easy to seat down and fit. Okay, and as you see on this one right here, okay, there's a big open contact because there's going to be porcelain built on this, and here are the margins open. They finish this back. Sometimes they'll wax this out in metal and they'll have to cut that metal back, but there's going to be some accuracy issues. So when you get your stuff back, look at it. Okay, this was one last year, and I took the die off, and there's a bunch of schmutz underneath there. It's like, what were they doing? Okay, couldn't they clean your stuff off? They're supposed to, but sometimes they don't. This came directly from the same lab that is making yours. So if you've got a debris field laying on there, you're probably not going to get that abutment, that die seated completely. All right, so I'd probably take it apart, make sure it's clean, and then try in your framework. Your framework was made to fit this cast. If it does not fit that cast, okay, then the laboratory has failed to meet their part of the manufacturing agreement, and they get to do it again for free. Okay? But if it fits the cast, but it doesn't fit your patient, then that means that you have messed up. Maybe your impression was deformed and you didn't know it. You made a cast, the lab fit it to the cast. Okay, so that is on you, and you get to pay for another one. Okay, so that's how that goes. All right. So sometimes there's going to be laboratory errors, and sometimes there's going to be clinical errors. And so, sometimes there's a little bit of back and forth going on between the dentist and the lab about who pays for what or who's responsible for what. But if you kind of know what's going on and you understand the manufacturing process, you can figure out who made the mistake. Okay, and if you made the mistake, hey, won't be your last. Okay, it happens. So you do have a metal thickness gauge, the Iverson gauge. Pull it out. If you didn't use it last year, you need to find it. You do have one. You're supposed to measure your gold crown last year with it. Use it and make sure you've got good thickness everywhere. Look at your connectors. Make sure you've got adequately good height on your connectors. Here we're showing that's 1, and there's the 5 mark right there. So that's 1.5, almost like 1.55 millimeters thick right here. Okay, here we're looking at a connector, and we are just shy of 3 millimeters. We're 2.7, it looks like. Okay, and that would probably work with a. This is a base metal alloy, so it's pretty strong. So margins should fit between 20 and 50 microns. Proximal contacts, one piece of shim stock should pull through. Occlusal contacts, all contacts should drag one piece of shim stock. Okay, but before you start to look at this from a definitive standpoint, okay, well, the porcelain still has to be added to this, right? So don't go hog wild and try to finish out the occlusal contacts, because it hasn't been made yet. But if you put it in and you're 3 millimeters high, you may have a mounting error. So you might want to remount and then send that one back. But if you're like just heavy on the contacts, that's fine. It has to be polished. And as you know, you're going to lose some material when it is polished. Okay, so don't finalize your contacts, your occlusal contacts with this. Even the proximal contact, if it's a little heavy, let it ride. Okay, they have to polish it. Okay, so if you over finish it, you're going to lose it. So don't do that. Okay. Now, in a real clinical situation, you're going to get this framework back on the master, but it is your solid cast that determines how accurate it actually fits. Okay. Yours, unfortunately, it doesn't do that because it's a dentiform. All right, and the problem with the teeth coming in and out. But clinically, you always want to have a solid cast, and you're going to determine how accurately your FPD seats on that solid cast. Okay, 99% of the time, if it seats on that solid, it's gonna seat just that same way in the mouth. All right, but you can't use that rule for this exercise. Okay, so look at the inside. Take a look at it. Did they give you the right Pontic form? Is this shaped? And that should have its initial shape correct. Okay, if it doesn't, you might want to do some metal work on it before it has porcelain on it. And here we have a framework. This is on a solid cast here, and can you tell that's not seating? Can you tell that's not seating in the back? Can you see that? There's your prepped margin. Here's your metal margin. So you've got about a good millimeter, maybe 2. So what's holding that up? What's that? Too tight of a contact? Yes, right there, right there. Now, if you were to disclose this, you probably wouldn't have any contact in the disclosing material because it's all hitting back here. Okay. So you've already seeded one crown, all right, last year, the one that you made. You seeded that. Here you're going to seed 2 more retainers. Okay. And then your last practical that you're going to have in this class is going to be a single unit crown. And you're going to have to seat it. And it's not going to fit. just a heads up, it's not going to fit. So you're going to have to find out why it doesn't fit and how do I adjust it to get it to fit. Okay, so this is kind of an art and science right here. So this is part of your learning process for this course, is learn how to seat a crown. Okay, now I used to randomly pick 10 of them that would not seat, for fun. But I don't, since COVID, I haven't done that because it just wasted a lot of time. And time is precious in this class. Time is precious in this entire second year for you guys. I know you are busy. So they're supposed to fit. Okay, I'm just going to throw that out right now. I told them to make them fit, make them all fit. Okay, and so you're going to seat this, and you're going to go through the process of your detective work of what's keeping this from seating. Now, hopefully, keep my fingers crossed. Hopefully, they just go right to place. Okay, but in the real world, it doesn't happen that way. Okay, there's always something there's just a wrench thrown in the works, and you have to figure it out. Okay. Now, if I have a fitting problem, I like to use the occlude on gypsum, on stone. You can use it on a plastic cast too. You can use it clinically in the mouth, but the green stuff, you just have to clean it out of off the patient's tooth. It gets kind of messy. So y'all watched the seating videos, correct? The disclosing videos, y'all have seen those? Looking at occlude and fit checker. And I think we had another one in there that we discontinued, but so you're gonna use that to adjust. So there's the culprit right there, too heavy of a contact. Now, if you can't get it into your patient, all right, and we're doing this on the mannequin, right? I don't want to walk in the lab and see you seating this on the bench top, all right? You got to have it on the mannequin. You're seating it. If you can't get it seated and you need to unscrew the teeth and screw them back in, you may take that off and do that little procedure and then pop it back on the dentiform. But for all your seating and adjustments, I want you to have it on the patient, okay? Because this is a clinical try-in, all right? And I like to use the check film, okay, because it's got the paper, the ink that rubs off. And so if I want to see where it's rubbing off on the interproximal areas, it's a really good visual indicator. I can see exactly where it's hitting, and I know where to adjust on the retainer. Okay, so and these things come, like a snake coiled up inside that container there, and they're really wide and long. You don't need all that. Cut a strip off of there, okay, and like this right here, and you can slide it into that interproximal area much easier to see where that contact is, okay, and give it a little tug, because if it's kind of a premature heavy contact, it's going to make a mark. So give it a tug, and then there it is, right there. There it is, okay. Black on one side, red on the other. It doesn't matter which color you have flipped over. It's just it's a two-sided ink piece of ribbon, and get this so that you can at least get the framework down. You don't have to finalize the contact. Please don't finalize it. Don't try to polish it, because if you get this to a high polish, okay, it's gonna, when it fires up in the oven at 1700 degrees, it's gonna get an oxide over it, okay, and that oxide has to be removed, Okay, and there's material loss when they remove the oxide. The shinier you get that down, the thicker the oxide. Okay, so I don't want this polished. All right, your Burlue, the rubber wheel, the what do y'all call it? I can't remember. Y'all have a name for it. What's the flexi? The flexi wheel. Okay, that's as smooth as you want it. You don't want to be using these brownie or greeny points that get it to a higher shine. You just want the flexi wheel, which is kind of a grayish color. It just kind of gets it a little bit smooth. It doesn't polish it. Okay. All right. If it's a real heavy contact, you can use the sandpaper discs. Okay. If it's like super heavy, okay, use the red garnet. If it's just a little bit heavy, use that white Cuddle disc. Has a much smaller particle size and removes less material. So use the appropriate abrasive for the job at hand. Okay. Okay. And then that should seat. Can you see this is fully seated now? Metal margins are matching up with the stone. Here they're not. It's kind of hard to tell this, but look at the lingual. Here's on the lingual. That looks like it's seated. Okay, so that looks pretty good. All right. So if I get to this point, then now I'm going to look at occlusal contacts on that molar. These two don't have any. Okay, they're porcelain, but they finally smartened up. And hey, you know what? If we put metal over here, we don't have to stack as much porcelain on there. Yeah, that's right. That's right. So it'll be easier for the technicians to finish those out and to build the porcelain on top here. So you're going to have metal contacts on the Pontic. It'll have porcelain on the facial, and same thing on the anterior retainer. So. Okay, you can also use AccuFilm. Now we don't have this in the MDL, but we do have it in the clinic, and it's like a blue. Oh, never mind. Y'all wouldn't know what typewriter ribbon corrector is anyway. It's like the old typewriter ribbon corrector. Oh well, can't relate to that. But you paint this on here, and it leaves just a real thin layer, and you seat it on there and it rubs off, as you see here. So that's AccuFilm 4. AccuFilm 4. It's not a tape, a ribbon like the AccuFilm that we use in the clinic. Of course, now we don't use AccuFilm. They changed the name of it to Check Film. Used to be AccuFilm 2. There was an AccuFilm 1. It had one ink, one-sided was inked. AccuFilm 2 was double-sided ink. I don't know what happened to AccuFilm 3. I think it got lost on the drawing board. And then AccuFilm 4 is like this paste material. So, but you will have that in the clinic. The other one we have in the preclinic and the clinic is this Fit Checker, and everyone's used Fit Checker. Yes, raise your hand if you've used Fit Checker. Ooh, raise your hand if you have not used Fit Checker. Okay, y'all need to be using Fit Checker today. Okay. Don't tell me in the clinic next year, oh, Dr. I've never used Fit Checker before. I'm going to pass out. Okay, you're supposed to use that stuff, so use it all. Use it all. Now, Fit Checker, it's real easy to use in the clinic because it doesn't stick to the teeth, but it sticks to your ivorine teeth in the preclinic. So that's an issue. So to use it in the preclinic, take a little bit of Vaseline, place it around the tooth, and then you're going to load your Fit Checker into the retainers, and then seat it. All right, seat it all the way. You should have a little bit of excess, kind of roll out like this, and you can tell when it sets because it's rubber, it's silicone rubber basically, but it sets fast. It sets pretty fast. And when it sets fast, it's going to come out in the crown itself. Okay, we'll save that for later. There it is right there. And what I'm looking for, I'm looking for any show throughs in the fit checker, just like I would look for with the what's that? The occlude, yeah, the occlude. And you can see here, there's a few little show spots. That one's metal showing through, and of course, when it gets thin, it starts to get kind of grayish, as you see in here. But right there, you can actually see metal is exposed there. If it gets so thin that you don't see metal shining through, it's probably not a high spot, but certainly if there's like a little nodule or something like that, you're going to see metal. Okay. And then after you adjust it, and you can adjust it with your handpiece and your burr just right there. You don't have to remove the stuff. Matter of fact, if you remove it, and it's like, oh crap, where was that? Where was that little spot? I forgot now. Now I've got to do it again. Okay. So leave it in there and just do your adjustment right there. Then you can peel this thing out. Okay. It cleans up much easier than the occlude. Occlude, you got to scrub and wash and steam it. And this stuff right here, it just peels right out. Okay. So here's another frame, and that one's not seating. And there's no contact impinging back here. No contact. So where's it impinging? Where's that? It's going to be impinging on one of these axial walls. We don't know which one because we can't look inside there. That's where you need your disclosing agent. Okay, fit checker, occlude, whatever you want to use. Okay. Okay, so it's binding on these two axial walls here. Why would it bind there? What's that? If they are really straight, yeah, you're going to get some binding, and if they've done any seating in the laboratory, they may have already adjusted this. So one of the first things I look at when I take it out of the little jewelry case, I look at the inside. Do I see any adjustment, any areas of adjustment? No, well, it looks like it was freshly sandblasted. Wait a minute. Did they adjust it and then sandblast it? Oh, that's what I did when I was the technician. Well, I don't want the doc to see me adjusting this crown. It's sandblasted. Oh, look at that, brand new, fits great. Okay, so I know all their little tricks. So look to see if it's been adjusted. Maybe they had some distortion and it shrunk in a little bit. Okay. Remember, if it was cast, you're going to have metal shrinkage. You have investment expansion. You have metal shrinkage. So God only knows if it's going to fit. Okay. Now these were not cast. These were printed. So we don't have casting errors. So if you are going to get some impingement, it could be because parallel, or there could have been a slight undercut. Okay, if it's a slight undercut, the machine, when it designs your coping, will automatically block that out for you. So as a technician, oh man, that's great. Somebody's doing my job for me. But if I'm making it by hand, okay, and I don't block out the undercut, okay, it's going to be locked in, and I have to adjust it out when it's cast. Okay, so why is it not seating? Where is it binding? And I want to fit really well, not like socks on a rooster. If you've never seen what socks on a rooster looks like, there they are right there. There's some socks on the rooster. That's not supposed to fit well. Okay, socks on a rooster, that's not a good fit. If it doesn't fit and we have to section it and seat it in two pieces, then we will get out our cutoff discs and we will proceed to cut it in half. Okay. When I was in the military, one of my laboratories, I made sure that they kept up their soldering skills, because if you don't solder for a week or two, you get lazy and you forget how to solder. But if you solder every day, oh, you get good at it. You get good at it. So all of our fixed partial dentures were cast in 2 pieces. And at the try-in, you tried in one crown and then the other retainer with the ponic. Then you spliced them together with the index. And that was a regular, that was a routine, okay? And our laboratory became very proficient at soldering those. So how does this look? That one there looks pretty good. Now this one here, if you look at, do you see the you can see where they've added extra wax, and so you've got metal coming out to the margin. They're going to cut that back before they add the porcelain on there. This is, some technicians like to do it this way, and of course that was handmade. That was not machine made, printed. So that one there looks pretty good. And this is hot off the press. Where's Maya? Oh, this is yours, Maya. This is yours. And Argent Mill Cobalt Chromium 3. This is the powdered alloy, and so these are milled or printed, additive milling, and this is what it looks like. It actually fit pretty good on the cast, but on the underside, what's going on with the underside here? What do you think? Sorry to put you on the spot. It does fit though. It fits the cast, so hopefully it will fit your patient. And this is looking at the occlusal, but I don't know, that surface there is just really rough. I don't know why it is so rough, but it is. And I don't know if they plan on. I don't think they planned on putting porcelain underneath there. Do you want porcelain or do you want metal contacting the tissue? This is for everybody, not just Maya. You want metal? Okay. Anybody want porcelain? You want porcelain? Okay. One metal, one porcelain. No other takers? What works the best? What's the best for the tissue? Glazed porcelain. Glazed porcelain is going to be smoother. But you can polish the metal. I mean, we have all metal fixed partial dentures. We still make them today, and you can't put porcelain on there, but you can polish that so it's nice and shiny, and it'll do just fine for the patient. But so I don't know what their plan was, but I do know this. Looking down at this, here's the anterior retainer, and you see they got a little bit more cut back here to add porcelain for that contact. But look at the ponic. What kind of a ponic did you ask for on your prescription? Do you remember what you asked for? A hygienic? Who asked for a hygienic ponic? Raise your hand. A modified ridge lap? Okay, is that a modified ridge lap? No, it's not. What is it? No, that's not a hygienic either. That's a full ridge lap. Is that a good ponic? You don't want that? Okay. Well, what's Maya going to do? Send it back. Okay. To be honest, we got one like this from one of our laboratories yesterday, and oh yeah, I was a little pissed at them, and because we asked for a modified ridge lap, they gave us a full ridge lap. It was even more ridge lap than this, and that's about, and it had the porcelain on it, and that's about 2 hours of labor going in there with a disc and trimming that off to make it modified ridge lap, and then you got to polish the porcelain, okay? And you can't take that disc, you can't let it get away from you and nick the margin over here, because if you do, then you start over. And if you correct it and you nick it, you bought it. So we sent that one back to the lab. Okay. Do what we told you to do. It's on the prescription. You send the original prescription form. Sometimes they just don't read the prescription. I don't know what they do. Okay, but they don't read the prescription all the time. So what you're going to need to do is this back end here. You're going to have to. It needs to sweep up so that only this portion here is contacting the ridge, and this portion, this half here, is not. So you'll take that same disc that you would use to cut off the connector or the sprue, and I would just start shaping that. Okay, it's best if you do it now than when the bridge is fully made. You're going to have a lot of porcelain to adjust and polish too, and then you're going to have opaque showing through. It's not going to look pretty. So so you need to do that now. And so we've got to get these bridges seated, adjusted, and then a new prescription form and turned back into Michelle today, because the lab's coming back to pick this up. Okay, so they can get going with the porcelain. So here's the Argent Mill cobalt chromium, and this is showing you the 66% cobalt, 27% chromium, 6% molybdenum, and less than 1% of your silicone, iron, and manganese. And oh, look at the modulus of elasticity, 233 gigapascals. Okay, what is your zirconia bridge modulus of elasticity? You're lucky if you get 1100 megapascals. Just need to be just right there, gigapascals. Okay, megapascals. So this is going to be strong. All right, it's going to be strong. It's going to last a long time. Okay, so how about this one here? What do you think? That seated? No, this one's not seated, but this one's seated. So ooh, we're gonna cut that connector, and then boop, that one's gonna go right to place, and then we're gonna send it back, and they're gonna remake it. Now here's the lingual. Oh God, Lee, look at that. That's way off. That's way off. That was one of the misfits that I asked for. Okay, and man, were they good at misfitting when you ask them to? Okay, so you have a couple of discs. I think you only have the skinny one here. Okay, I don't think you have the thicker one. This one's good for just all around cutting. This one's only good for sectioning connectors. Okay, it's really thin. If you stare at it too hard, it'll break. It'll just chip. Okay, so it's hard to get this thing through the connector without breaking it. Okay, so hopefully you have 5 or 10 or 15, and you should be able to get through one connector. But it's skinny, and you can make a skinny cut through that connector, and that's what you want. Okay, if you take off too much, you can get the space too wide, and now you're going to get an error in your indexing before you've even started. So so you're going to get this baby going, and you want to cut straight through the connector. Usually I'll put a little section in the top, and then I flip it over, and then I'm gonna go from the bottom, because you're cutting this kind of blind sometimes, and I don't want it coming out on the margin, because I can't see what I'm doing. Okay, so it's going to be really important to section these nice and straight. So usually I'll prop my arms up on the table to kind of get good firm grip. Okay, and then holding this die, because it's if you're putting your fingers on that margin, it'll cut into you. So put the die on there, hold this thing down, grab your handpiece, palm, thumb, grasp, and then you're going to join the two thumbs together to kind of stabilize it. Okay, and then away this baby goes. You're going to spin it pretty fast. The maximum rotation for this is, I don't think you're supposed to get up to 15,000, but somewhere around 10, 11, 12,000 RPM is what you want to use to cut that. And so everything is braced, brace. Okay, because if you have any little movement in there at all, then chink, your disc shatters, and you have to put on another one. Okay, so make sure you're good and stable. Here's the initial cut right there. And then after as you're cutting on this, it gets hot. Okay, it gets hot. So I have a bowl of water, and when it starts to get too hot to hold it, don't wait till it starts burning you. You don't want to be smelling burning flesh. Okay, and then sink it in the water. You'll hear that, you know, it's hot, and then go back and continue cutting. Okay, come back. And here's the connector. Oh, look at that connector. Oh, that's nice looking. Good vertical height, good facial lingual width to it. That baby, that's strong. That's strong, and that's what you want. That's what you want. Okay, and here is our space. Okay, now I want a certain amount of space in there. I don't want it too small, and I don't want it too large. This is like Goldilocks and the porridge. Okay, I want it 0.25 millimeters. Too wide. Too wide. So I get distortion errors if it's too narrow or too wide. So about the thickness of a business card, which is 0.25 millimeters. And nowadays, everybody prints their own business card. There's no telling how thick or how thin. Some are really thick, some are really thin. So the business card thing really doesn't work anymore. But 0.25 millimeter is the gap that you want. Okay. And here's your little flexi disc. Okay. And you need to get this thing out and do some contouring. Don't be polishing it with these. Keep those back in the kit. Oh, this is the Notre Dame before she burned down. I don't know what it looks like now. Okay, 5 principles of soldering, and you won't be soldering, unfortunately. This was a big day in the lab because we get to cut your bridges and we got to do some soldering, and that was fun. That was fun watching your bridge glow orange before the solder flowed, and you know. So, but you need to know this. You need to know the steps in the process for the national boards. Parts clean, parts hot, parts close. Gravity. Gravity is going to help the solder flow, and access. You need access into the solder joint. Okay, and we used to use flames back there. There's a particular zone in your flame that is called a reducing area. Okay, if you see number 3 right in here, here's your reducing area here. This is the combustion zone here. This is the mixing zone. And if you look at the outer part, the yellow part, that's where it's already starting to oxidize. So it's a bad thing to have the oxidizing zone around your parts because it's oxidizing your metal, which you don't want. So the solder is not going to stick to an oxidized surface. So when you clean the connector off, you prepped it, you removed all the oxidation off of that, but you can re-oxidize it by putting the wrong part of the flame in on it. Okay, so look at these 2 gaps here. Here's the optimal gap. It's 0.25 millimeters, and it's straight. Okay, it's straight. All right, I don't want it 0.25 up here and then 0.5 down here. Okay, that's going to give you a little bit of distortion. Okay, this one here is too wide. You're going to get more distortion with this than you will with the 0.25 gap. All right, and you better know that one because, well, you should know that by now. Okay, now here's one that's kind of lopsided, and this happens a lot because when they don't fit real well, there's positional errors when you cut it and you seat it down on there. Okay, well now you see how it distorted. Okay, and so if we have one area wider than the other, I'll try to make these the same size. So if I have to widen this area to match this, I'll do that, and then I'll select a solder that has a really thick flow property. Okay, the solders that have a higher gold content in it, like your 650 solder, it'll just blow right through there. Okay, so you need less gold in it so it doesn't flow through there as much. So you can control the flow and the shrinkage with the type of solder that you use, but that should be uniform, not different gaps in between there. Everybody with me? Okay. This is one that's too small. Okay, if it's too small, and sometimes you make that cut and you get them seated, and it's like, oh, wait a minute, they're still hitting. Okay, well, it verifies the distortion that you had. So now keep adjusting it so that they don't hit, and so that you get 0.25 millimeters in between. Okay, but if you get them and it's just real thin through here, your solder is not going to flow into that area. It needs gravity, heat and gravity to flow through there. It won't flow through there. It'll only cover the outside area, and it's going to be real weak. And when you're done, one of the first tests after it cools off, you grab it and you try to break it. Okay, if you can break it, okay, it wasn't very strong. Okay, because you should not be able to break this thing. It's going to be like a tank. And it's because the solder, here it is right here. It didn't flow anywhere in this other area. So it just does not flow well in there. So, okay. So as the gap width is increased, the strength will increase, but then you get to a certain gap and then it starts to decrease. Okay. Distortion always increases with the gap width. And of course, capillary action always decreases as you get closer together. It just will not flow. Okay, so that connector, when you cut it, it should be fairly rough if you use that disc, but you don't want it to be polished or smooth. You want a little bit mechanical roughness to it, and so your garnet sandpaper disc is a really good one to kind of just lightly roughen that up. You could even take a 50 micron aluminum oxide sand and sandblast that surface, and you'd be fine. Okay, you'd be fine. Come on. Then after you get that shaped, you're going to steam it, get it nice and clean, and then you're going to pull out your sassy cups. Okay. And a bender brush, and you're going to pour some. Now we use excuse me, a GC pattern resin in the clinic. I don't know why we don't use it in the pre-clinic. We use Duralay, and Duralay is okay, but Duralay is not as accurate as the GC pattern resin, but it works the same, and it's the same color. Okay, so you're gonna pick up a little bit of monomer with your brush, and then dip it in the powder, and you're going to bead brush and fill that gap with acrylic, and you're going to connect the two, right? You're going to connect the two, and don't do it like this. I couldn't hold. I didn't have three hands when I was taking the picture. One of your classmates needs to be holding this rascal on there, seated, okay, and then I'm going to hold this one on here and make sure it's seated, and with the other hand I'm going to bead brush and make sure that flows all the way through that cut connector. All right, but if you don't have some pressure on that molar, the sheer weight of the ponic will just, it'll just tip up, and okay, well you didn't capture it in a seated position, so that's not going to work either. Okay, so this is what you would do clinically if it didn't fit. Cut it, put it back in. Now do they fit? Okay, and chances are they will fit. Connect them together, and we're going to send this back to the laboratory, and then they're going to solder it, and then send it back, and we'll try it in again. Okay, so once that connection has been made, then I'll take a little bit of extra material and place it on the top. Don't do that on the bottom, just do it on the top. And then I'm going to make a stone index on top of it. Okay, and it's called an index. The Duralay is called an index. They're both called indices. The one on the top I'll make for Justin, just in case. Okay, because after this is soldered, then I can take the assembly and try it on that stone index, and it should fit. And if it does not fit, then cut it again, solder it again. Okay, I don't want to have to try it in the patient's mouth to see that it's incorrect. So you can do that in the laboratory, but you need 2 indices. This is a tooth card. So don't throw away your tooth cards when you set your denture teeth. They make excellent little matrices for the index. And so I can set that in there like this, and I can tell if it's seated accurately or not. Okay. Okay. So then that goes to the lab. This goes to the lab, and then what they will do is they're going to invest this soldering index. Yeah. So they're both of these, the red Duralay and this stone, they're both called soldering index, soldering indices. Okay. Then we're gonna solder it, but it's not called soldering. I don't make this stuff up. Okay, this is years of misuse, mispronunciations, poor terminology. There's soldering and there's brazing. Okay. Okay, there's soldering and there's brazing. And whether you solder or braze, it's going to be dependent upon the temperature of what you're doing. And the cutoff is 450 Celsius or 842 Fahrenheit. If it's below that, it's soldering. Okay, and many of you have soldered using a lead solder and your little soldering stick. And any stained glass? Anybody make stained glass? No? Okay, you do a lot of soldering with the stained glass to get all the pieces together, or electrical boards or whatnot. Brazing is what the plumber does when he comes to fix your copper pipes. He's going to connect them and braze, put some braze around it, and that's at a higher temperature. And that's what we're doing in dentistry. We braze. We really don't solder, but they call it soldering. Okay, so sorry for the confusion. Okay, so just make sure here. There's soldering. There's soldering. Okay. So and it's going to melt and flow by capillary attraction between the parts. So when you're doing this, you're gonna have the FPD in 2 pieces inside the investment, which we haven't talked about yet, but it's going to be inside the investment, and it's going to be on a Bunsen burner below it, and you're going to have soldering torques on the top, and you're going to put the heat. I try to put the heat on the Ponic because that's a big mass of metal. Okay, but your parts need to be hot. That's what the parts hot mean. The number 5 retainer and the Pontic need to be glowing. Don't put the flame on the solder is going to be you're going to have it sticking in that little crack there, the little cut. But don't be tempted to put that flame on there. It's going to melt and go everywhere. You're going to oxidize everything, and now you got to do it over. So you keep the heat off of that little solder piece. The heat from the metal should melt the solder and pull it in by capillary attraction. Okay, and that's when you learn how to manage the process. Soldering or brazing becomes very easy to do. Okay. There's brazing. There's brazing. And here's brazing. Here you see the glow of the Ponic and this retainer here, and the solder's just kind of wedged in between there, but you're putting the flame here and kind of brushing it between the two, and that heat from the metal of your fixed partial denture will melt and pull the solder into that spot. Okay. Just a note on soldering investments. They're similar to casting investments. Okay. But they're not casting investments. But what do casting investments give you? They give you expansion, right? They give you expansion. Soldering investments do not give you expansion, because we've pieced these two components accurately in space, and I don't want any expansion, and I don't want any contraction. Okay, I want it to hold the parts accurately. So how does it do that? Well, it has a lot of fused quartz in there as the binder, which will not give you that expansion. Okay, so just remember that, fused quartz. Okay, low setting expansion, and that maintains the accurate dimensions of the fixed partial denture. Okay, okay, and it helps to prevent the parent metal, that's your fixed partial denture, from melting during the process. And oh yes, that can happen. You can melt a retainer usually. Okay. Okay. We also weld in dentistry. Okay. We weld, and that's a stick welder. Welding, it's a fabrication process. It's going to join the metals in our case by using fusion. Okay, fusion. So so we're going to have not the solder material is an alloy of its own that will melt and fuse the two pieces together. When you weld, you're using the parent metal. So in this case, you would have a piece of a welding stick from the Argenco cobalt chromium, and it's the same elements, but there'd be like a stick of it, looked like a solder stick, and you'd cut a piece and you'd put it in between, and you could use it to weld and tack weld it. Okay, so welds are much more it's quicker to do, more accurate, and it's just really fast. Here's one of my technicians using one of the first dental lasers we got in the military, and he's you can look through the little microscope through here, but we have a closed circuit TV over here, and you can see a whole lot better on that TV. So he's welding by looking at the TV. Okay, and here's you see the stick right here. That's the parent metal, and he's just zapping it away. And so you would zap, and you would try to do, and then this is kind of a artist rendition. That's not an actual laser, but the laser will come down and hit that piece, and you can hold it in your hand. Okay, just don't get the fleshy part underneath that little beam, or it's about 2,000 degrees. It's really hot, and it will hurt. It will hurt. So here we have a hole in the casting, and the technician, here's the rod, the parent metal, and he's just zapping it away and filling in that hole, going round and round and until he's done filling it in. So you're gonna spot it in. And here's one with an open margin. Metal bad castings. We didn't have remakes. We had reworks. So you had a margin that was open. Yeah, just weld it, add to it, finish it, polish it, and that's what they're doing here. They're adding a little bit of metal on this, and you can add as much or as little as you want. Cut that off, and then use sandpaper disc, finish it, and it's very, very accurate. Here is an implant bar, and they're welding the two pieces together. So you don't even need an investment for this. You can invest it, but you don't need one. Okay, and here they're welding a broken RPD clasp together. Okay, could not do that with a brazing process. Could not do that, but you can with welding. Okay. Okay, bless you. Okay, two types of solder joints or braze joints. One is a pre-solder, one is a post-solder. Okay, a pre-solder is what you would do with this framework that you're getting today, because the porcelain's not on there yet. If it didn't fit, we'd cut it, index it, and then they would do a pre-solder. So the pre-solder that they're going to use, the material it's going to withstand the temperatures of the porcelain firing. So it's going to go up in the porcelain furnace and fire at a real high temperature. Okay, we could do a post solder and add metal to a PFM framework, and that one there you would invest just similar to the pre-solder, but the soldering material would not have to withstand that high of a heat. Matter of fact, you'd want something at a lower heat so it didn't affect the porcelain. Okay, so two types of solders: pre-solder joins the metal components before the porcelain application, and then the post solder is they're joined after the porcelain application. Here we have a full metal crown and a PFM crown. Okay, and these are soldered together to two implants. Okay, you couldn't cast them that way. Okay, but the advantage of the gold here is that it's burnishable. It's just easier, more accurate to cast than the PFM metal, which is a little bit trickier. Here's another PFM unit that is soldered to a gold crown. So that's a post solder. Okay, porcelain's already on there. And you can use a flame, you can use an oven, you can use an infrared oven to solder this. We use gases, and I know we use different gases here. We have what do we have? We have natural gas. We cast with that. That's about 900 to 1,000 BTUs per cubic foot. Okay, and we also have propane. We have propane. Oh no, we have butane. Butane. I think it's butane in the clinic from those little red jobbers that I see people border molding with. Yeah. Okay. 3,200 BTUs. Ooh, that is a hot flame. So if you're doing anything with butane or propane, you're putting a lot of heat into it. And if you're putting that on compound, it's not made to heat up your compound. That alcohol torch is made for that. Your alcohol torch, your wood alcohol, it's about 800 BTUs. So it's a cooler flame. Okay. So anytime you're flaming compound in the clinic, you want to use a low heat. If you're using butane, you might need to set it in the water and let it cool for 30 seconds before you put it in the patient's mouth, or you're going to light them up. Okay, so so it depends on. You can use any of these in the laboratory for brazing. It doesn't. There are some little nuances. I think acetylene gives you the cleanest burn over propane, and of course, if things don't go well, okay, well you can lose it. You can lose it. It'll just melt. And here's our soldered or brazed connector. Okay, and so it's when the capillary attraction pulls it down in there, you're going to get this little ellipsis right here on the top and the bottom, actually surrounding the whole thing, and that's what you're looking for. Okay. Okay, and of course your solder must melt at a lower temperature than the parent metal, right? So that should be obvious, all right? Otherwise, it goes back to the other slide where things didn't go so well. So and here's some pre-soldering up here, porcelain firing, and if you need to solder it afterwards, you're going to do a post solder, which is going to be even a lower temperature material. So fusion temperature is always below the parent metal, but it's not as low as you might hope it would be. It's between 90 and 180 degrees Fahrenheit. Actually, it's usually closer to 90. So that's not a real safe range for you. So you just have to be careful. Okay. You want this material to be corrosion resistance, tarnish resistance, color compatibility. I don't care. as strong as the parent metal for sure, and of course you don't want any pitting in there. It will come as a component of gold, or at least most of these solders will. What is this? 535 or 530? 530 fine. So that's 53% gold. Okay. Compare that to there's 530. What is this one? Gold solder. Fine, it doesn't say. Oh, that's a pre-solder. Okay, there's not going to be much gold in that. So a 650 is popular. I think we have 650 back there. I think we have 615. So that's 65% and 61.5% gold. The more gold it has in it, the more flowable and liquid it's going to be when it melts. Okay. And so why solder? Solder, you can refit parts together if it doesn't cast accurately. And that was always a big thing with predictable and accurate. So it has been a pretty good thing to use in implants. We always had an issue with the lost wax technique in casting these accurately. It just never would. Even to this day, it just can't do it. Can't do it. And the other issue is that can you make an impression that can pick up all of your implant components accurately? And for the most part, no, that hasn't existed until very recently. Okay, so we are just now able to capture these accurately and make an accurate bar or frame across here using photogrammetry as the impressioning process, and using CAD/CAM milling to machine the bar. So in the past, we've always horsed around with it by soldering, and that gave us the most accurate result that we could get. The tolerances for implants are much higher than for natural teeth because there's no ligament around them. There's no room for error. With natural teeth, you do have a little bit of room for error. You might think, oh, that's an accurately fitting fixed partial denture. Well, is it? Or is it shifting one of the teeth slightly into its periodontal ligament in the socket and you just can't see it? I'm sure that happens all the time. Not a clinical problem though. Okay. So here's the 650. That's 65% gold. So it's based on 1,000. 615 is 61.5%. And then here's your pre-ceramic white pre-solder. This is a high temperature solder, and proportion of pure gold per 1,000 parts. So that's how solder is divvied up. The higher the fineness, the greater the gold content. Okay. The higher the fineness, the more fluid the molten solder. Okay. And to wet this, borax, called a flux. Borax is a common flux, so that will help the solder get the metal surface wet. Okay, so you want to have some flux in there, and typically you'll dip your piece of solder in the flux and then place it onto the fixed partial denture block that you're going to solder. And it's going to remove surface oxides and prevent oxides from forming. And this comes in paste. Most of what we use here at the in the MDL is going to be a paste. I do have some powder, okay, and we can use powder. We don't have any liquids. And of course, you use this in ortho too. Y'all haven't had ortho yet, have you? You have. So have y'all done some soldering in ortho? Oh, yeah. Okay. Well, this is the flux that they use in ortho, and we use it in this class too. So an anti-flux is something that prevents it from sticking. Okay, so flux is good, but an anti-flux can be good too, because where do you not want the solder to stick? The occlusal surface. It can't, you can't have enough heat on there that it spills over and covers your occlusal surface. And margins, okay? Or if you're trying to solder a proximal contact, you don't want it running all over the proximal surface, so you can put an anti-flux around the spot where you want the solder to stick in hopes to confine it to that region, okay? So rouge is a good anti-flux, and so is graphite. Just shave off part of your pencil and put graphite, and it will obstruct the flow and adhesion of solder, okay? So today in the laboratory, we're going to seat the framework on the mannequin, okay, on the stick, and do your laboratory QC form. I receive that you're to turn that into me, but have your bench instructor, if you see something that's not good, like no occlusal contacts or something like that, or if the margin's open or something, get your bench instructor to look at it, and if you need to identify and have them sign it, do that, and then eventually it comes to me. You're going to get a new prescription form, and you're going to give that to Michelle. You'll fill it out just like before, except this time you're going to have the shade on it. Okay. I think polycarbonate crowns are due today. We've graded a lot of those. I don't know how many are still outstanding, but if you can get those to me today, that's great. And if you have to wait till next week, that's fine too. I want you to get this bridge project done first, though, because it's got to go back to the lab. All right, so make that your priority. And I haven't seen too many number 11 preps. So this is what your prescription form should look like. Again, you can put your name up here and the bench number, okay, and then D4. Oh, wait a minute, that's I thought I deleted that one. Dang it. This is metal, so there's no shade here. Ponic is D4, PFM is D4, and you're just going to say, okay, put D4 on there and send it back to me. Okay. Yes. Question.
Yeah. For the soldering index, do you do one or the other, or you do both?
You'll do both. One's for the lab and one's for Justin. They're both for the lab. They're both for the lab. Okay. But that's if you have to do that. I'm keeping my fingers crossed. I'm hoping that nobody has to make one. But if we do, gather around and use it as an educational opportunity. Okay. Because you will be held responsible for doing that in the clinic if it doesn't fit. Oh, what I do? Well, haven't you done this before? Well, look in your manual. You know how to cut things into. You know how to cut it, make the cut, measure it so it's 0.25. Get your dur layout. Okay, you can do this. All right. It's actually pretty easy. Now the soldering part, okay, now that's tricky. That's tricky, but you don't have to do that. And even in the clinic, you're going to send that back to the laboratory with both indices, and then they're going to solder it for you. Okay, we don't even have a soldering station over there.